Hi friends, in today's lecture we will understand physics and technology behind fuel cells, a magic device which converts fuel directly into electricity. So let's start. First, physics behind fuel cells. Consider this reaction where hydrogen and oxygen react together and forms water molecule. And Gibbs energy change of this reaction is negative in most of the case, so this is a spontaneous reaction. And if we check state of this water molecule in detailed way, it will be like this, where hydrogen and oxygen will be in ionic state as H plus and O2 minus ions. And during this reaction what happens is each hydrogen atoms lose one electron, so hydrogen becomes hydrogen ions, and these electrons are gained by oxygen and it becomes oxygen ions. Finally these ions combine together and forms water molecule. So you saw there was internal electron transfer between hydrogen and oxygen. An electron transfer is same as electricity, but since it was internal it is of no use. If somehow you could make it external transfer, then we can use it for some useful purpose. And that exactly what a fuel cell does. A fuel cell will force this electron transfer through a external circuit. And in next section we will see how to do that. Here again the hydrogen atoms have just released the electrons and it is about to be gained by the oxygen. But in a fuel cell what you do, you will cleverly introduce a barrier in between. A barrier which will transfer only hydrogen ions through it and not these electrons. And for transfer of this electron we will provide an external circuit like this. So what will happen here? Since these electrons cannot flow through this barrier, it will flow through the external circuit and will produce electricity and will combine with oxygen and form oxygen ion. And since these hydrogen ions can sneak through this barrier, it will flow through the barrier and will combine with the oxygen ion and it will form water. So here we force the electrons to pass through the external circuit by a clever introduction of a barrier, thus produce electricity. And this is the basic working principle of any fuel cell. But the real challenge is conversion of this working principle into an actual working engineering device. In next section we will see that. So in this section we will develop the principle we learned in last section into a working technology. Here the gases are separated by a barrier as we saw in last section. And there are dozens of barriers available in market for fuel cell purpose. And the kind of barrier you are selected for your fuel cell will decide what kind of fuel cell you are using. It is so important. And for this example we are using a barrier called membrane electrolyte. A membrane which will allow passage of only hydrogen ions through it. Next important components are one anode and one cathode. Function of anode is to aid this reaction. It acts as a catalyst and it will help in dissociating hydrogen into hydrogen ion and electron. And most commonly used anode is highly expensive platinum material. Cathode also acts as a catalyst for this reaction in order to combine hydrogen ion and oxygen ion to produce water. Now the next important component of fuel cell are gas diffusion layers. It is there on both the sides. And main function of GDL is to allow transfer of gases through it. It's a porous medium. GDL also helps in removing water formed here after the reaction by providing a compartment over here. And GDL should be a conductor of both electricity and heat in order to remove heat from the system and in order to transfer electricity produced in the system. If we check voltage produced by such a single fuel cell, it will be very low. It will be in the range of 0.5 to 0.6 volt. Such low voltages are not useful for any purpose. So what we do in actual practice, we will stack lot of such single fuel cells together in series way so that you can augment the voltage. And these bipolar plates are used for that purpose in order to support connection of one fuel cell to another fuel cell. So bipolar plates are acting as an electricity collector. It also helps in distributing gases on both the sides. Now the final component. Obviously there should be a current collector to take electricity produced to the external circuit. So here it is. Now we will have a look at step-by-step electrochemical mechanism inside this fuel cell. Here both the gases are supplied on the side of bipolar plate. So it will get distributed all over the bipolar plate and it will pass through gas diffusion layer like this. And the hydrogen molecule upon reaching the anode will get dissociated into hydrogen ion and electron like this. Since these electrons cannot penetrate through this membrane, which prevents that, it will flow through the external circuit like this and it will reach the cathode side. And at the cathode side it will combine with oxygen and will produce oxygen ion. Now hydrogen ion in anode can sneak through the membrane. So it will flow through the membrane until it reaches cathode side, where these ions combine together and form water molecule. Most of the time, this water produced will be in vapor state due to high temperature of fuel cell operation, and this water can be carried away by flowing air, so it will be out of the system. This kind of fuel cells are known as proton exchange membrane fuel cells, or PEM, one of the most versatile fuel cell available in industry. And before winding up the lecture, we will go through some advantages and disadvantages of fuel cell technology. Here it is.